Now you joined here.
Me, I've subscribed. I don't want notification.
So now we are live on YouTube. If you prefer to join the session from YouTube, you can comfortably do that. So now we are live on YouTube. If you prefer.
Okay.
Yeah, I'm going to get it.
So I think it will be good for you to subscribe to the channel so that you get prompts like this, and it makes life easier for you to connect with what we are doing in class. So you can subscribe to the YouTube channel so that anything like this, you get an alert. Otherwise, it can escape you. And for the purposes of improving the connectivity, please, I request that we put up our videos just to improve the connectivity, right? And also to maintain sanity, we have to put our microphones off. We only need to put our microphones on if we are passing information to all of us for the purposes of the learning. Otherwise, it will be ideal to put the microphone off so that we don't get interference from the background. Thank you.
So please, we can't hear you.
Hello? Can you hear me now?
Yes, please.
Whoever is sharing the screen should stop doing what he's doing. Otherwise, he gets punished severely, please.
Okay, sir.
You just join the class and listen to the lectures. You're not supposed to do what you are doing. Okay, so we are getting ready to start. We have about 85 class students, which is a good number to start with. Before we start, let me try and give a brief overview of what we want to do today. If you can't hear me well, please let me know so I do what I can do about it. And try to also pay attention. Don't distract yourself. Don't try to tamper with any of the settings there. I think for the purposes of listening to the lecture, the features that you need for the class is the chat or the Q&A, where you can raise your concern and then we all can share ideas through that. Trying to do all the kind of things you are doing, please, if you do that, I will not be happy with you, I tell you. So let's all comport ourselves. It's also advisable that if you are not talking, if you have not been given the platform to comment or ask a question, it is in the interest of all of us that your microphone should be off so that we don't get feedback from your environment. We are not interested in your music. We are not interested in the voice of the people at your background. Let's all comport ourselves responsibly so that we have a nice session. Thank you. So we have been trying to deal with the concept of relational database. And then we are implementing relational database with Microsoft Access. Reason is Microsoft Access gives us some smooth learning curve, which can take us into the world of relational database so that we can smoothly navigate. It's not too difficult if you start with the graphics like Access will make us do. We know how to click some buttons to create database tables. We know how to establish relationships between database tables. We know how to create forms as the interface of feeding our database with data. We know how to query the database for information, at least in a fundamental way. And then we said, in the world of relational database, you are likely not to be clicking stuff like we did with Microsoft Access. Microsoft Access is specifically designed for small business where you can run it from your desktop up to about maybe medium sized. So if you want to scale up your knowledge to be able to use, relational database to manage bigger institutions, then the go-to way of doing it is to know the programming behind what we have done. We want to introduce ourselves to the SQL programming language. For our level, we will not go so deep, but it will be a very good foundation for whoever wants to build on it to go deep into the world of database to get all the advantage that it presents. I will encourage you to take these things we are doing seriously, and I'm not exaggerating, I am not boasting. This is what gives you a job. It's not the things you fake yourself chewing and pouring, not at all. Every person who needs you to join his or her company needs you to have real skills that solves real problems. It's not coming to define things from textbook. No, it's not a business they do there. So never be lazy about understanding these things, because if you are not lazy, you'll see that these things are cool to understand. Is that all right? So let me share my screen so that we go over how we created our database during class. It was a simple club database where we tried to keep information on membership, like members profile, where members work, the dues that members have to pay. And then we also added something like programs that the association or the club probably will run. Maybe we can get some money from there, sort of. So that is what we have been trying to do, and we want to just see and take ourselves through it. We have done it all together, so everybody's aware of it. I just want us to have a view of it, and then it refreshes our minds on what we have done so that we look at how we can use the programming language SQL to do the same thing or almost the same thing. So let me share my screen at this point in time. When you join the session, please put your video off to help us improve the connectivity. If you are not talking or if you don't have a question to ask, your microphone should be off, just to sanitize the session, please. If you can see my screen, please let me know, right? So that I know I'm doing the right thing.
Yes, please, we can see.
Thank you. All of us are familiar with this interface. From the hands-on sessions we've had in class, we created, so let me close these sessions and try to show you all the stuff we've been trying to do. We were designing a data access database for social club management. So what we have, how we conceptualized the system is that we decompose the system into these logical units called entities. We will need data specific to members, data specific to members. So we have members entity. We have members entity. Please, if I find someone disturbing the class, I'm a good person to remove the person permanently from the class. If you're not answering a question, if you are not asking a question, your microphone should be off. This is simple rule. If I see someone's microphone interfering my lecture, I will just remove the person from the class. So these are the entities we created. And of course, we have done entity relationship diagram with some nice software like Draw.io or Microsoft Visio. So you can have something similar to this. Members or member entity, dues entity, programs entity. So maybe we have to make this one also members because all of them are almost plural. And then occupation entity. And you can see the tables which are representing each of these entities here at the navigation pane. So you can see dues table. So at the navigation pane, you can see sections for each of the database objects. So this is table, and you can see all tables below that. And then we have queries, and you can see the queries we have run on the database under the heading queries, and forms that we have created for the database under the forms heading, as you can see here, where I'm hovering my mouse. So in the meantime, we are talking about the tables representing these entities. And then you can even see from the entity relationship diagram that I'm showing you all the attributes. And these are terminologies you need to be very familiar with. Your quiz might try to test you on some of these things. It's very fundamental to understand them. So these are the attributes. We have member ID, and all of you at this point in time should know what it is. By the way, you also have to understand this session is also a tutorial ahead of our impending quiz. So if you have some questions, this is a good platform to ask. If you are not able to answer all of them because of time, we will try to have an arrangement for us to respond to the additional questions. So you can see the attributes.
Sir,
Yes, please go ahead.
so about this, how should I say it? This form, how we got here. I still don't get how we got to this part. Can
No
you
problem.
please take? Okay.
No problem. Maybe time will not permit us to go over all of this, but you can come to the office for clarification. And I will advise that most of your friends who are close to you. And sometimes when friends teach you, you get it better. Sometimes. So I will advise that you can watch, first of all, watch videos on it because people are busy. So if you can get it understood by watching some video on YouTube, by reading some text on the internet, you don't necessarily need to go and waste another person's time. If you do all these things, I'm sure you'll be cleared. And if you are not still cleared, remember learning is you reading and watching some videos or listening to some audio, a combination of these sources of information. That's what learning is. Learning is not like someone has to tell you what you have to go and read. Someone has to tell you what you have to go and watch. That is not learning. So I will advise that you do your part of the learning by watching some YouTube video on how to do entity relationship diagram. And I think you'll be fine. If you still have a problem, come to the office. I mean, you can talk to your friends, or if you are still not clear about your friends trying to explain to you, you can book a session in the office. We'll try to help you understand it. Please, your microphone should be off. Are you okay, please? The person who asked the question.
Yes, sir. Yes, sir.
Yes. Okay. So we see the attributes in each of the entities, member ID. So we are talking about this one, the member attribute, the member entity, sorry. So these are the attributes: member ID, first name, surname, gender, date of birth, marital status, phone, email address. This is what in class we discussed to be the data we want to capture on the members. And then you have to understand what the first attribute represents. It is a bit unique because you can find some key attached to it. It serves a special purpose. This field or this attribute is referred to as a primary key, and its main job is to ensure uniqueness of records in the table that we will create for this particular entity. And all of the database tables should have that kind of property where we have a unique identifier field, which tries to guarantee that every person we are putting in there is unique so that we are not duplicating the same person, sort of. Yeah. So that's it. And then we also talked about how we make tables communicate with themselves through the concept of table relationships. With table relationships, we talked about three main table relationships in relational database: one-to-one, one-to-many, and many-to-many. One-to-many being the most common kind of relationships, followed by many-to-many. One-to-one, not so common, except in cases where we artificially even create them. And we also learned about how to do the relationship between the tables. First of all, you need to naturally assess whether it makes sense that the two tables should communicate. For example, member table keeps member-specific data, like we have talked about. First name, surname, gender, date of birth, marital status, phone, email address. When we're learning about the principles of relational database, we learned that we do not lump all data, multiple data into one table. So we try to decompose the system into these logical units, and we keep the data specific to each logical unit. Where we need to do a report, where we need information from here and here, that naturally tells you that those two tables have a relationship. For example, you will naturally need a report where you want members information and the dues that they have paid. This naturally tells you there has to be a communication between the two tables, a relationship between the two tables. And then you ask yourself a further question. What is the type of relationship between member and dues? And we talked about exactly how you do the assessments. For example, when I have one member like myself, Joshua Ado, how many connected entries can I have in the dues table? I can have one, well, I can have 0, I can have 1, I can have 2, I can have multiple entries. This is how it comes about. I can make a payment, 1, which may not be full payment. If it is full payment, that is the fact that I have made, I relate to just one record in the dues table. But if another person pays in trenches, in installments, let's say the dues is 1,000. So initially he pays, let's say 500. Another time he pays, let's say 200. And then the third time he finishes the payment. That means that you can track that same single person from the member table to multiple connections in the dues table. And that makes it 1 from the member side to many on the due side. And that is not finished yet. You also have to look at it from one entry in the dues table and how many entries it can connect to in the members table. For example, if we take one payment, each one payment can relate to only one person. There can never be one payment which is coming from person A, person B, person C. It doesn't naturally work that way. So from the dues to the members, it is 1 to 1. And the way we finalize the relationship is that we use the number, the bigger number. From member to dues was 1 to many. From dues to member was 1 to 1. So it ends up ultimately becoming 1 to many, as you see it here. When I right-click on the relationship line, we can access the properties here. So let me go to edit and see something. So we can see that at the bottom here, relationship type, we have 1 to many. And you follow similar logic in establishing relationship among all the tables. Where there is no reasonable relationship, you don't force the relationship. You don't force it because we don't force a relationship. So for example, if you look at the program entity and therefore the program table, unless maybe someone gives us a solid reason why he thinks the program table talks or relates to any one of the other table, I didn't see it so. For example, when we do a program, how does the program relate to the members? The program is a block thing. It doesn't get generated from members. It is autonomous of every member of the group. And of course, the program doesn't also have a relationship with the dues. It doesn't seem to have any sensible relationship with the dues. So it is for the occupation as well. So you see this one stays on its own. So there can be cases like that where the table doesn't connect. The data is in it. When we need it, we access it. But every instance where there has to be a communication, you need to just do that. Otherwise, you will not get the full functionality of the database. So in our simple club social club database. This is the logical design. This is the entity relationship diagram, which we are going to use. So this is like the building plan, which we are going to use to create the building itself in this
Sir, please, I
database.
cannot.
Please go ahead. Someone was trying to talk. I guess maybe the person is okay now. So let's go ahead. So that is what we have done. We have done all of these things in class. If you couldn't take 4 parts of the class, consult your friends, watch the videos we have shared, read the text we have provided, and you should be fine. If you still have doubts, try to ask questions in the groups that I have created for you. Learning communities are very useful in actually championing what we are doing. This is a hands-on course, so you always have to be in a community and share ideas. It is not something you can chew and pour. If you try it, you will fail and fail and fail and fail. I am not intimidating you. I am just telling you the truth. Do it the right way and you will see you can score 100%. It's cheap when you do it with the right mind. It's extremely difficult if you want to cheat. And when you are cheating yourself, not anybody. So my advice is that you sit yourself down and practice. Just know how things are done. Don't just fake yourself, please. Otherwise, you get troubles with the course. So this is just about the building plan of the relational database, in this case, our social club database. This is the logical design or the building plan, if you like, which we have to translate into the database. And the way we translate it is that for each of these entities, we create a table for it, implement the table for this. So now we are going to see the tables. If you have any questions of the logical design I'm just showing, you can ask. If it is about how to do it, we are not going to redo it. We have done it in class. Just go and fill the gaps you have. You can patronize the learning communities that we have created, watch the videos we have shared, ask questions, and you should be fine. Aside from you wanting us to redo it, if you have any other questions, you can ask. Okay, no questions, great. So this is how we implemented this plan. We created database tables for each of the entities. And then we implemented the relationship. So we want to see how we did it. For the members table, this is how it looks like. We have some data in it so you can see it well. This is how the members table look like. The member ID, which is the primary key, first name, surname, just all the stuff you saw as the attributes of the entity. They are becoming fields or column names for the table, and this is how we do the implementation. And the way we do it when you are creating the table for the first time is to open the table in design view, like you are seeing now. And then you will see field name. So you put all the field names which are the attributes in the entity, you put them here as column names or field names. And one important thing in the concept of relational database is what we call data types. In legacy databases, maybe you wouldn't care so much about the data type for which data you are creating for the database. If you are using Word tables or maybe Excel tables, you just put a 10 there, not caring so much, but that is where you get your troubles from. We want to save ourselves from all the troubles associated with those style of keeping data, and that's why we are learning this technology. So we have to do it the way it is. we have to assign the appropriate type to each column or each field. Member ID, access, and most relational database management systems provide a way to automatically generate that number. So it's a number, some series of numbers or digits, which the system automatically generates. And the idea is that these numbers will never be the same for any two people. So normally you don't supply this information. This is system generated. We just created a field for the system to generate and dump the data into it. First name is text, like your name. You type text, you don't type numbers for your name. So it makes sense. Access gives it short text. But in the broader space of relational database, there are data types like varchar. Let me see if I can access this thing to write it for you to see the spellings. I even doubt if you can see it because I've not shared it. No problem. So let me try to type it somewhere here. I'll erase it. So this is how the varchar looks like. Varchar. Some people pronounce it varchar. It doesn't really matter. All you need to know is how you write it. It stands for variable character. So when you do variable character, what you are doing is, and a character is for text. Character means text. The word variable means that we want to create the type such that the space which is allocated for whatever we are typing responds to the amount of characters we are putting there. So if we type 30 words, it just allocates a space based on the number of characters we have typed. That is varchar, and that's the meaning of the var in the varchar. Var for variable. There is an equivalent, there's another one which is called char or car, like this. There is no var before it. So this one is fixed. So normally this is what we do. Varchar, and then you specify the characters that you think should go there. So if I specify, let's say 50. So for varchar, well, you have specified 50, but if you don't type 50 characters, it shrinks the space allocation to what you have typed. It doesn't reserve the whole 50 space, even though you don't use it. But char, when you say char or car 50, it is going to allocate a space for 50 characters, whether you use all of it or not. And sometimes this is not efficient. Maybe other spaces, it can be efficient, where you know that, oh, I mean, for this particular field, this is the characters that need to be there. You can make it fixed. For example, let's say gender, the gender field. The maximum, the longest text that we can put there, I am thinking the traditional where we have male and female. Nowadays, they are saying we have so many things, which I don't understand. So based on the traditional gender thing, we know male and female, the longest will be the female, which is FEMALE, 6 characters. So you can use car or char and say 6 because you can never go above 6. Well, that may also not be too efficient because it means that where you type male, which is less than 6 characters, you still have some reserved space which is unused. So even in this case, you might want to do varchar 6. And when you do 6, well, fine. If you do male, which is MALE, which is 4, it shrinks it to 4 characters and takes away the excess spaces which will be artificially created in the database to make it slow. Okay, so Microsoft is representing these standard relational database types or data types with things like short texts, and they even have long text and stuff, right? So that's how you do it. So we've created and assigned all the appropriate types, and that is not a big deal. It's very simple to do it. If you try to do it by just reading it, it will be a big deal, actually. It will be difficult for you. The easiest way to understand these things is that you need to make your hands dirty. You need to make your hands dirty. Put your hands on the keyboard. Do it and get the mistakes. Then get your head bashing. Oh, why am I getting this? Why am I getting this? And that is where you get triggered to seek knowledge, to seek explanation of why things are happening that way. If you're just reading it from a textbook, you wouldn't challenge and get into that experience. So that is how you have to learn it to get it easy. Otherwise, you always say it is difficult and nobody's going to listen to that talk because it has to be difficult. That's why you are here to learn it. If it were cheap, you don't need to pay the money and time to be here. And that's why I'm teaching you, because it is difficult. And actually, it is not difficult. Learn it well. All those people who are saying it's difficult, please deal with your laziness. We all can be lazy. I am lazy, and I have to deal with my laziness. Everybody is lazy. Everybody can get into the trap of laziness. Let's fight it. Your laziness shouldn't conquer you, conquer it, and this is fine. This is cheap to understand. Okay, so that's how we do it, and a similar routine is followed for all of the other ones. So we don't need to actually look at them. And besides, we have done it in class together. If you didn't come to class, actually, that's your own decision you made. So we created all of them. And then, for example, the member table, we said, has a relationship with occupation. And the relationship is that members have occupation. And the occupation belongs to the members. So that's how they are connected. In relational database way of doing things, it wouldn't make sense for you to create one big database, one big table, and put members and occupation together. We have broken them, and then we can make them communicate. So this is how we did it in terms of creating the relationship. So you can see that when you come to the occupation table, and let's check the field names or the column names. We have occupation ID. Let me enlarge the columns for you to see all the names. So we have occupation ID, which is system generated. And we have occupation name, company name, which is where the person works. And this information belongs to the members. So when we are done capturing the occupation specific information, we should have a way of saying that, okay, this information I've kept on occupation is for this person. So we create another field in the occupation table, which will pull the values from the members table. It will actually pull the members ID and then link each entry into the occupation table to that person's member ID. But Access gives you some nice way, because it's difficult to remember numbers. But that's what the system actually is using. That's what the computer is using. But for your sake and for your eyes and for the way we like doing things, you can choose to see the names, because you know that, okay, this is for Joshua Aldo, this is for Esther, this, blah, 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 better than using their numbers. Actually, what we do is that when we create this field is called foreign key field. It's foreign because, one, it doesn't naturally belong to the occupation table. it actually belongs to the member table. It's just the member table ID, the member table itself, because every table is represented by its ID. So we are kind of representing the member table here. And if you are coming into another person's territory, you are a foreigner sort of. So that's why we call it foreign key, which gives us a way of assigning all the entries in the occupation table to the members which those information belong to. And that's the same style you use to do all the other relationships. So if you know how to do it once, you know how to do it all times. I mean, in all circumstances. Any questions so far?
Yes, please.
Go ahead, please.
So, in creating a relationship, is it supposed that the foreign key must be at the child entity or it must be at the parent entity?
Every foreign key is in a child table because the reason why we call it a child table is because the values, for example, here, we are saying that by bringing this member ID representation here, this table becomes a child table because it is going to be fed with the values we are putting here from the member table. And if someone is feeding you, you are a child to the person, just like your parents feed you. We explained it in class. Go and read over your text. You should be fine. So that's what we use to kind of identify which is a child table, which is a parent table. Are you okay, please?
Yes, please.
Thank you.
And please, another question pertaining to the members, whereby all the details, all the columns, all the non-key attributes talking about contacts are being added to the member table. Please, does it not violate the normalization principle that you said? It says that there shouldn't be repetition of multiple columns when it is being done like this.
So what is the multiple columns in this case? Be specific. Let me open the member table because that's what you are using for the reference in your question. So let's open the member table and then you show us the repetition that you are talking about.
So with the latter part, we talked about phone address and everything. Phone and address, which is trying to talk about the contacts of the person, ways through which they can reach out to the person.
Yeah, it depends on how you are doing your designing, right? I have explained this overly and overly in class, so I normally don't expect that you take us back to re-explain ourselves. The design we chose does not make it any repetition because phone is not exactly the same as email. So are you telling me that when we ask you for your phone number and you supply your email, it's equivalent? No. So these are not the same concept for you to call them repetition. What I described as repetition of columns is like, let's say you want to keep, the person has multiple phone numbers. So you have, let's say, phone 1, phone 2, phone 3. That is tautology, kind of saying the same thing. And there's a way of handling that thing so that it doesn't become like a tautology. And we have discussed it in class. You can go back to the lectures and you'll be fine, okay?
Okay, sir.
So this is okay. Any other questions? Thank you for your question. Any other question, please? Okay, so let's go ahead. So we have done all of these things and we have 1, 2, 3, 4 tables, which is the representation of or for our 4 entities, as you can see here, 1, 2, 3, 4. This is how we convert this logical design to the physical design of creating these tables and the relationships among them. In fact, and we created forms. These are things we did in the classroom. If you didn't come for the class, we are not going to redo the class. Today's session actually is now beginning. This is just a repetition of what we have done already with a mind that we want to clarify some doubts. So this is a tutorial session. Now let's look at what we want to do for today. These tables we have created. So everything mainly is about the tables. These things are mainly graphical stuff. But the tables, this is where we use the SQL language to create them. Instead of doing them the way we did by going to create and hitting table, going back to, let's say, design view, specifying the field names and assigning the appropriate types, and even tweaking some properties of the field, instead of doing them through this graphical interface, we could have coded them. We could have written them in code, because I told you that when you click here and a table is generated, the computer doesn't understand this thing that you see here like a table. It doesn't understand click. What is happening is that some code is embedded under this click. So when you do that, it sends the code to the computer, and the computer understand, okay, this is the code, this is what you want to do, and it does it for you. So the best way to do this programming is to know the codes yourself. That is where you get the power to go very high. Otherwise, these graphical things will limit you. So we want to, at least as part of the course, introduce ourselves to it. That session is not going to be what you will use to master the SQL language, but we have to introduce ourselves to it. That's all that we want to do. So at this point, I am going to maybe open a new Access database. And how you create the database in Access, unfortunately, you can't write a code to write it, but a simple code to write a database, SQL code, is create as an English word, space, database as an English word, space, and then the name you want to give to the database. Then you end the statement. So this is a statement. The statement ends with semicolon. But in Access, we create it by creating an Access file, which will go and sit on your computer hard drive. Implementations in higher RDBMS, like Postgre, Microsoft SQL, Oracle, MySQL, SQLite, and those things, there are plenty. You can find and read about them on the internet. The implementation is a bit different. When you open, you will have to create the database. So you say create database and the database name. Access doesn't have that one. So let's see how it goes in Access. I'm going to create a new database. Let me see if I can do that here. Yeah, so blank database here. I'm going to create it. Yes, and then I'm going to call it, let me call it SQL. So SQL dot ACCDB. It's okay. And then I'm going to save it in my document. Do you want to save changes to the layout? Okay, so it's going to exit. I think let me do it simple. Let me just close this one. This one we use it for tutorial. So we are done. Let me close it. And then open a fresh Access as if you are creating a new database. Okay. So now I'm going to create a new database, and then I'll share that with you. So I hope you are seeing my screen. If you are not seeing it, please let me know. Are you seeing my screen, please?
Yes, please, we can see.
Yes, so I'm going to click here, blank database, and then we are going to call it, let's say SQL underscore maybe access. Trying to say that, okay, we are implementing access through SQL, sort of, make it any descriptive name that makes sense to you. I'm going to save it in my documents. Okay.
Hello, sir. Sir, please.
Automatically.
Hello, sir.
Go ahead and ask your question, please.
Please, whatever that you are doing, it cannot be shown on the screen. It is the old thing that is on the screen. That's the one that you
Okay,
use.
thank you. So let me unshare it, and then I reshare the right one, right? Okay, now can you see a new database created with a default table? Confirm for me, please.
Yes, please.
Yes, sir.
Yes, sir,
Thank
you can
you.
see.
Thank you. Okay, so this is the behavior of access when you create access database file for the first time. It opens access with a default table called table 1. We are not going to graphically design them, so let's get this table off. So now this is what you see. There is no table. You can check from the navigation pane. Nothing is here. And now let's go to create. So this is how we use SQL to do what we said, what we have done already. Trying to go over some of them for you to see how SQL does it, basically using the codes. So when we come to create, instead of coming to create table, we will go to query design. The query design has a section where you get access to SQL editor. And then we can program our tables, create our tables by writing the codes in the SQL editor. So we're now going to query design. So this is what we have for query design. You can forget about everything you are seeing. I think I need to close all of these stuff. Then what you do next is to, have you seen this? The views section. When you click on the drop down, you see 2 views, design view and SQL view. So we're going to go to the SQL view. SQL view is mainly designed for querying. That is why you see the keyword. And here, please, you have to bear with me. I don't have a means of making the text appear larger, but can you see it? There is some text here. Here is select. Can you see it? It's so tiny.
Yes, please, you can zoom in.
Yeah, so when you're watching the video, you have to get your eyes close to it. All right, I mean, by theory, the query editor is mainly designed for you extracting information from your database through the select statement. So by default, you see the select statement there, but you can clear it if you're not going to do any selection, any querying. Now we are going to create tables. And at this point, you can go to the notes I sent you. It will be a good guide for you to connect to what we are doing. And you will just realize that it is not difficult. So let me use the opportunity to talk briefly about the sub-languages within the bigger SQL language. In the text that I provided to you, I introduced you to these sub-languages. These are the sub-languages under the SQL language. Data definition language, DDL for short. Data manipulation language, DML for short. Data control language, DCL for short. Transaction control language, TCL for short. For this particular session, we are going to talk about DDL and DML. So DDL, what is DDL? DDL is used for defining and then modifying the structure of the database schema. When we talk about the database schema, the main objects there are the tables. And sometimes you can get table views and so on and so forth. So at this level, think of the DDL as the syntax for creating the tables and then modifying the table structure and then deleting the table. That those statements that you write to do those stuff, they constitute the DDL, the data definition language. So we are going to do DDL because we need to create our tables before we can even select. So select is later. So how do we do that? The statement to create a table is very simple. It's English and it is shorthand English. It is written as create table. Then you supply the table name, and then in parentheses, you supply the columns and the type, the columns and the type. Then I'll talk about other constraints you can put on the type, like is the field, sorry, on the field, is the field a foreign key field? Should it be assigned a property like required so that you have to type something there before you move on? You can set those constraints. In standard SQL language, those things that we set up as properties like required to yes, and so on and so forth are called constraints. They are just meant for the database to behave in a specific way to kind of make it
Hello, sir.
yes, please go ahead.
Please, I can only see the blank sheet. I can't see anything you are doing.
Yes, for now it is only blank sheets that I'm showing. Okay, now let me try to type something in that blank
Okay.
sheet for you to see. If I type something like create, are you seeing the create being typed? Sorry, I missed
Yes,
that.
please. Yes,
You
please.
can see now, right?
Yes, please.
Thank you. So I have not typed anything, that's why.
Okay.
So we are creating a table, so we say create table, and me typing this in capital letters is just a way of making what you are doing more readable and more nicely organized. This is what we do. All the keywords that comes from SQL itself and not you, like these are reserved words that the database uses to understand what you want to do. Create, which means that you cannot call any of your tables create because it's a reserved word. And then table, you can't call any of your tables table. So those keywords that form the syntax, we type them in caps. And then the words that come from you, because you have to provide the name you want to give to your database. That one is not a SQL reserved word. We type those ones in small letters. And that makes what we are doing sensible to know, okay, this is this and this is that. That's all. Apart from that, you can type everything in lowercase, but it's not just going to be nice to know which is a keyword and which is not. You can type everything in caps. It is not case sensitive, but we write it this way for us to get things easier for ourselves. So create database, and then our first table was, sorry, create table. First table was member. Sorry, so this has to be lowercase member, just to adhere to design principles. Member. Then I do space, I mean open parenthesis. Then I have to now supply the columns of the table and the type for each table. You can type it long, but horizontal, but it doesn't make much meaning. It makes reading it difficult. It's not nice. So if you refer to the notes I gave you, we try to type the same code in such a way that when you look at it, you can see the table structure even within the code. So normally what we do is this. We will try to come down after typing open parenthesis. You'll come down, and then if you like, you can do even 4 spaces or any number of spaces that you think is good. So I'm going to do 1, 2, 3, 4. And then I'm going to supply the field names. So the first one was, what was it? The first one is the primary key, right? So you say member
ID.
Member ID. And then we go to space. So the next thing we do is the type, the data type. If we want it to be automatically generating the numbers, there is a SQL syntax which will help us to do that. I think the name has escaped me, but we can find it. So let's have a way to simply find it. It's something around what we were doing, auto something, but let me be sure about it. So give me just a few minutes. I'll get back to you soon. Okay, so I mean, you at your side, you can also search it. The type there is auto increment. Auto increment. Yeah, so anytime you are stuck with something like that, I'm just giving you one of the ways you can help yourself understand what we are doing without necessarily asking someone to explain and so on and so forth. So now let's get back to it. So member ID, then the type is auto increment. That's the type. And then space. We want to set a constraint on it. The constraint is that we want to dedicate it as a primary key. So we add that keyword primary key. And when you set this constraint, automatically the values there will not accept nulls. So it is like you have set the required property to yes, sort of, because it's an ID. So anytime it has to be there. Then you say comma. So the various columns in the table are separated by a comma. This is something very simple to understand. The syntax is not too cumbersome. The name of the field, member ID, the type, auto increment, you want to make it a primary key. These are the constraints. Or you want to say it should not contain null values. So you say not now. We'll talk about it, that one too, later. Then we are done with specifying the column. So you say comma. Then you come down. This is just for readability's purpose. Coming down, because I did 4 spaces, I do the same thing. And then I come to the next column name, which was, what was it? First name. So first underscore name space, and then it was text, but we have explained the standard SQL version of it, which is variable character. So I'm going to do varchar 30. I think that's what we did when we were designing it, 30. So that's the type, variable character, which is equivalent to Microsoft Access text space. So we have finished defining the basic structure of that column. But do we want to set any constraint on it? Do we want to say something like, oh, it should be required such that you have to type something there? In standard SQL, you will have to say not now. It means there should be a value. You don't entertain null values there. That's why you are specifying that constraint, not null. Right? Then I go to the next column. So I do comma, come down, still want to follow the design. So I come to surname. What is the type? The same varchar. Let's say 30 characters. But if you don't type up to 30, the meaning of var there is that it will shrink it from 30 to whatever you have typed. And then let's say this one to not now. It means you have to supply value there. The moment you want to create a member, you can't create a member without the member's first name and surname. It's fundamental. That's why we are putting that constraint on it, not now. Comma. What is the other field name? Gender. So let's say gender. Gender is of the type varchar. So I'm going to make it simple. I don't know of any other gender type except male and female. That's what we are going to do here. So it should be varchar for the type. And we are going to make it, let's say 6. For the highest number, female. And if you don't type up to 6, it shrinks back to what we have typed. For here, we will not want to set a constraint, not now. We want to be a little bit flexible. If you don't supply all, maybe it's not too much informative. When you are querying your database, do you place so much importance of members being classified as by their gender, male or female? Only in a few circumstances. So maybe at this point, you'll be flexible. You will not set it not now to make it by force to supply. If you think it makes sense to do it, so just do it. I am just going to skip that one in the meantime. So I'll do comma, come to the next column name. What was the next column name? Please, you have to speak back.
Date of birth.
Date of birth. So we do date underscore of underscore birth. Sorry. And then the type is date. There are other date types apart from date, time, and other things. You have to read more on them. So we do date. And here we will not be too strict and setting it to not now. So we are done. The column name and the type. We come to the next one. Tell me, what is it? The next column name.
Yeah, where did you take this one?
Right,
There's this one I took, but I came to meet.
Marital status. Good. Marital status. The type is character. So we are going to do varchar. And let's say we are going to do it I think it's going to be married, not married, and those kind of stuff. So it's not going to take too plenty characters. So let's make it 20. And because it is varchar, if you don't use up to the full 20, it will shrink it back to what we have used, which is so efficient. What's the next one?
Address.
Address. Good. So address, that's the column name. What is the type, the data type for the column? Varchar. So varchar, and let's make it for address 255. I'm trying to say, okay, the address can be trying to write so many things to describe a location. But if you don't use up to this whole 255, the benefit of varchar is that it will shrink the space to whatever you have typed. Yes, question, go ahead, please.
Yeah, please, with a varchar, you're saying to shrink it back to something. I didn't get that side. You shrink it back to.
What are we talking about the varchar? You should understand it. The varchar is the data type, and we are saying is the characters you are typing there. For example, the address, the figures, or the text, whatever you're going to press your keyboard to type. Those are what we are calling the characters. And then being variable character means that when we allocate this space, have you seen how we are defining the varchar? Varchar into brackets some number. That number is an allocated space or number of characters. Var is going to help us such that, see here, marital status, I have put 20 because, so the meaning is that we have reserved 20 character space there. If what I'm typing for marital status for a particular person is just 2 letters, it shrinks it from 20 to 2. So this here will be 2 for that particular instance where I typed only 2 for address. Another person's own can be 15. So it shrinks it from 20 to 15. Are you now okay with that explanation?
Yes, sir.
Yes, sir.
Good. Okay. Do we have other attributes that we have to? I think that is all. Other column that we need to do. That's all, right?
The phone.
Phone, okay. So I think the phone was, it doesn't matter where you place it anyway in relational database, the sequence doesn't matter. So now, even though in the original design, phone was somewhere at the top, it doesn't change anything for us to put it here at the bottom. So now we have phone, sorry, let me keep to the tradition. So the column names that is coming from me will be in smaller cases, and the keywords from SQL will be in caps. So I am calling this column name phone. That name is coming from myself. And the data type is something within SQL, which we are using, we are borrowing and using. And therefore, that's the reason why I'm typing it in caps, just to differentiate the two. So phone is also going to be varchar, and I explained the other time why, even though phone is 0, 2, 0, 1, 2, 3, 4, 5 digits, but it doesn't make sense for you to store it as a number. So we are going to say varchar, and nobody should ask me why, because I've already explained. Varchar. And then we can say the other time we were discussing of, oh, if you want to write all the things that we write for a phone number, given, also considering international way of writing it, we can also even think of not doing the plus. I think the plus stands for 0, 0. So if you do 0, 0, how many for a full phone number? What will be the maximum characters? You can set it here. And this one, yeah, we can do it varchar because maybe not in all instances you write it full with international quotes and other things. So where you don't write it like that, varchar will make it shrink to the characters you have typed. So that's why we are using varchar. But if you are going to be robotic or if you're going to be that kind of rigid and say that, okay, this is the style I'm going to write the phone numbers, regardless of what. So maybe you're going to say, this is a local social club. We are never going to get a member who comes from the US or the UK, and therefore there might not be the need to write the numbers in international code format whatsoever. In that case, all the phone numbers we use in this country, I'm just going to read the digits for mine. 0, 2, 4, 6, 5, 1, 2, 6, 5, 5, 10. So in that case, if that is a policy that you are going to use, you might want to drop the var and say char, car, and then you say 10 because it can never go above 10. And it can never go below 10.
You don't see a printer.
Are we exhausted with all the columns?
No, do you want to see a printer?
Please, is the email the same as the address?
No, so it means we have email to do, right? So that means we have to do another comma and come down and say email. Thank you. Email, we are also going to store it as variable character. So we do var for variable, and then car. That's why some people say it's car instead of char. So car, character, variable character. And then let's say we want to make it 50, guessing that no one's email address can span more than 50 characters. You just have to intelligently guess this one. We don't have a formula for this. So I think by this time we are exhausted with all the column names we have to create. So last one means that there should be no comma. The comma indicates that there's another one to come. If there is nothing else to come, you don't bring the comma. So you check if every question, please go ahead.
Please, I have
If you have a question, yes, go ahead and let's save time.
I have a question pertaining to the lookup wizard, as in, so the gender per se, when we are creating the gender and everything, and we want to do a lookup for it, can we use a SQL over here to create the lookup, or we need to create the entity table, then we go and do the lookup in the entity table?
Okay, that's a very intelligent question. Actually SQL doesn't have that straight way of creating a lookup. It's access specific stuff. So we don't really have a SQL code to directly do, for example, let's say on the gender, we have some keyword we can type here, which will make it automatically a drop down. No, it doesn't exist in standard SQL. So when you are done with this basic block work, you can go to the graphical interface and do some of this tweaking. Are you okay?
Yes, please.
Thank you. So we are done with the basic block work. So you can run it and see, and if your code is done perfectly, it should create the table. So now you can see that have you seen that the table has been registered in the navigation pane called member? If you are seeing it, please let me know so that I know we are on the same.
Yes, please, you can see.
Yes, please,
Yeah.
we can see.
So this was made to happen by this code. So it is like all the clicks we did before. When you click, some code like this is being generated and sent to the database engine for it to interpret your click as what you see, like a table like this one. So we can even now let's save this one, save it. Let's call it SQL SQL underscore member. Just trying to say that, okay, this is member table, or you can also say member before the SQL. If I do SQL member, I'm saying, okay, this is member table created with SQL language. Let me make it like this, rather. Member and say SQL. The meaning I have in my mind is that it's a member table. I created it with SQL code. So I say yes. And then it will put that code here for you. You can get back to it if you want to edit it, blah, 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 blah. One restriction you find in Access when you are using SQL to do your database programming is that you cannot use this same window, this query design window, to create multiple objects. For example, I've created member. So maybe I come down and specify the code for the creation of dues. And then no. In higher level RDBMS like Postgre, like Oracle, like MySQL, and so on and so forth, that is possible. You can write a full script for all the tables and run it once. It will create all the tables. That seems not possible in Access. For now, I experimented with it. I even read about it, and it was confirmed that Access is a bit restrictive when it comes to that way of doing it. So it means that for every table, you have to have its own code in a separate SQL editor, and then you save it like we are doing. Now, if you want to open the table and see, you see it as the first one where we came to create and specify all of those things. They are the same, but this time around, we have done it through coding. Is that okay?
Yes, sir.
Yes,
Good.
sir.
Yes, sir.
Okay.
So let's close it and then go to create query design. It means we're going to do another thing using SQL. And then let me come to SQL view, clear what is there, so we do what we want to do. Creating the other tables like dues, occupation, and programs follows the same principle. So we are not going to repeat ourselves. Now let's go to the next sub-language, which is DML, standing for data manipulation language. Now that you have the table structures, you can, of course, another thing you can also do still within the DDL, data definition language, is that, let's say you realize you need to add, okay, I think I should have even done that one, but that is an assignment, go and do it. Maybe we forgot about the email. You remember we were told the last time. So let's say we forgot it and run the code, and then our table is created without the email. And you want to go and then update that. Don't let me use the word update because it's a keyword for a different thing. Let's say you want to go and add, and that add is a special keyword which we use to add columns to tables. So you want to go and add that column called email. The syntax is very simple. You can refer to your notes. You just type alter table. Alter table is a keyword, just like we did create table. They are key phrases or key phrases. Alter table, create table, those things that we write in caps are key phrases, and they come from SQL. So alter table, then the table name, so alter table member, followed by the keyword add, so capital ADD. What are we going to add? Email and the type, the data type. Let's say varchar 100. We are done. It will go and dump that column to the table. So that is an assignment. When you are creating the other tables with SQL, try intentionally leave some out and later go and do the alter table statement, add the new column, all right? So now let's come to, we also have another a key expression in the DDL called drop. So you can use a drop to delete the table if you realize, oh, this table, maybe you have created a table twice or the table is no more needed. You just say drop table. So these are key expressions. Drop table, so all of them will be in caps. Drop table. What table or which table? That is the table name. Drop table member. Immediately you run it, boom, that table is gone. You have to experiment with all of these. Intentionally create a table, drop the table, recreate it without some of the columns, go and do alter table, add columns, then you are good to go. Now let's come to DML, data manipulation language. We have created the structure of our databases, the schema, in this case, the tables. Data manipulation language focuses on the manipulation of data within existing structures like the tables we have created. This includes inserting data into the structures, tables in this case, updating the data that we have already inserted, and then retrieving data from the tables. These are the things that we do inside DML, data manipulation language. And the key word there is the word. Okay, they have several things, depends on what you're doing. So now let's take them one by one. Let's say we want to insert. We want to put some values in the member table. So we do, and here it's going to be a bit difficult. Someone should help us do this. You need to know the order in which. Oh, I've not typed anything. You will see very soon. Don't worry, okay?
Okay.
Let's open the table. And then let's see and of course, let's see the table in design view, even though we didn't create it by clicking. You will see that it is very similar to what we did before when we were doing the clicking. In the design view, you can see member ID and it is auto number because we use that keyword auto increment, which you need to remember that this is standard SQL for, creating auto-generated fields or columns, auto increment. And then you have an auto number here. The first name we said varchar 30. So when you come to the property side, you will see that field size is 30 here. So that's the meaning. It's interpreting everything like the way you do the clicking and typing. And that's the power of the code. So please, someone should take note of the order of the columns. The reason is that when we are doing insertion into the table, we need to also remember the order of the columns because we type the values in that same order. Type the values in the same order so it goes and hits every column specifically as you have set it up. So has someone done it for us? You can forget about the member ID because that one is automatically going to be generated. So we have first name, surname. So someone should write it there in sequence. 1, first name, 2, surname, 3, gender, 4, date of birth, 5, marital status, 6, address, 7, phone, 8, email. Someone should do that for us for a guide. Just for a guide, please.
Sir, please, I've done it.
Thank you. Okay, so now we are back to the SQL editor where we can put some values in the table using the insert keyword. Anytime you want to, populate your table with data, you say insert. And insert is not what you are typing per se, it's a SQL keyword. So following the tradition, we type that one in caps. So actually, it is insert into. So that's the phrase, insert into. We are inserting into what? Or into, is it what or where? Maybe what and where, all of them can work. We are inserting into a location, and in this case, that's the table. So insert into, then you have to specify where you are inserting into. Member. Insert into member. And then you say open parenthesis and you close it as well. So sometimes it's good to do open and close at the same time, and then you move back and stay in between them and type. So open parenthesis here, we need to specify the columns of the table that we want the data we are supplying to go and hit. And when we supply it, in the order that we will supply it, we need to provide the values in the same order. So now we are going to put value in first name, and you have to make sure you type it the same as it is in the table because it's going to read the table heads. So first underscore name, comma, surname. I think these are the two fields that we dedicated as required, right? So just for the sake of time, because it's going to be the same thing, let's say we are inserting values only into these two columns. So that's what we do. We'll say like this, we specify these columns we want the data to go. And then we say we can come down, or you can type continuously. When we come down, we try to give it a structure which we think makes it more readable. So I say values, and values is also a keyword in SQL. This is the meaning of the syntax. Insert into a table, and in the table, these specific groups, these values. So you say values, and then you say into bracket. So the values should match the column names you have specified here. So values, then I say, let's say, Joshua. So because it's a character, you have to quote it. That's the way you make the computer understand, okay, this is not a traditional thing I want to see, which is a number, it's some other value. So, but keep it and store it for me. We do that by saying, putting the value in quotes. So you can do it single quote or double quote, but there are some weird situations. Sometimes some of the implementation platforms require you to be specific with double quote. So sometimes it's safe to type it double quote, just in case it doesn't accept single quote. Or you can read about it whether single quote and double quotes are equally acceptable. So Joshua, that is the first column. Then I do comma, oh sorry, the comma should come after the quotation. Comma, quotation, Ado, quotation closed. And then parenthesis closed. Take your time and look at the syntax well. It's very logical, it makes a lot of sense. Insert into the table name, which is member. Then we specify in parentheses the columns of the table. If it is all the columns, you supply all of them. Then you say values in parentheses, then you type the values in the order that you have specified the column names. And the first one, I think I forgot. SQL statements end with semicolon. but it doesn't make it a strict requirement. That is why if you don't even bring it, it still runs, but it's a good idea to do your things in a complete way. Okay, so now let's run. If everything is okay with our code, it should be okay. So run. And it gives this thing, let's take our time and read. And you have to always be interested in reading these kind of alerts. Sometimes it's kind of telling you some small mistake that is somewhere, or something you need to be aware of that before you do what you are doing. So it's always important to read the full report, whether it is an error report or something like this. So this one is saying you are about to append one row. Once you click yes, you can't use the undo command to reverse the changes. Are you sure you want to append the selected row? If you are sure, you say yes. So the data is inserted. Let's go and see. And then you will see Joshua Ado. Or you don't see it. If you see it, let me know.
Yes, please, we can see it.
Okay, so this is the simple broken English you write to tell the computer to do all the magical things that it is doing for you. And if you have to learn how to speak this broken English and do all the gigantic things that every human brain cannot do, I don't think it should be difficult for you, because you can't do the job that these things will do. You can't manage that database, big database in your head, but your mind can easily learn these things, and then the computer takes over that big work for you. That's the importance of computers in our lives. It's not for watching movies, please. Any questions? Any questions? No questions, great. So after inserting values, you might want to update. Sometimes, okay, maybe I misspelled the Ado or something. You can say update. That one is a word, it's not a phrase, update. Then you specify the table name where you want to do the updating. So update member in our case. Then you write another keyword, set, S-E-T. So we are setting some value. Set, let's say in this case, surname. That is where maybe I did a mistake. I mistyped the Ado. So set surname equals, now I type the right one. I type the right one. But look at how we are typing it. Update, update member table. Set. We specify a column and the value that it should go there. So we are only using the column names and the table names. Member, and then in this case, surname. But those names, the member and the surname, are for every member in it. So we add this piece of code. We add another keyword, where. So where, let's say member ID equals 1. That is if my name, my member ID is 1. So it's for that clause where member ID equals 1 is going to identify me from the table under that column we have specified and do the setting of the value. If you take your time and follow it, just after typing some, doing some on the computer with your hands, just about doing 1, 2, maximum 3, it will just get and locked up in your brain. That's how it is. There's a connection between your hand and your brain. If you don't get your hands busy, you don't get the connection to your brain, and you will struggle. You will think that what we are learning is difficult, but it is the most easiest thing in the world. Thank you very much. this is a brief demonstration. Our time is up about how you can use SQL language to implement relational database. And at a higher level, this is how you do it. More of this and less of graphical interface clicking. Your assignment is that you're supposed to experiment with the other syntax like updates. I've described it to you. You have the notes. The note is so clear for you to understand. We have insert. We have already demonstrated insert. We have delete if you have to delete some records. Let's say you have inserted someone. Let's say you want to delete a member. He's no more a member. He said he's not a member. So you say delete from. So that's the key expression or key phrase. Delete from where member, that's the table. Then you set the condition where member ID is equal to the person that you want to remove. Everything is clear there. Experiment with them. Put your hand on the keyboard and do it. Make the mistake. Think about it. You can figure out where the mistake is coming from. If not, read about, you can copy the error message, put it in ChatGPT. It will tell you and even add tutorials to it why the code is like that. Sometimes it's some small mistake and what you can do and some other things you can do. When you learn like this, everything will be cheap. This is where we will end today's session. We sought to demonstrate how SQL can be used to do relational database like the social club database that we created. Thank you very much for your attention. We have a few minutes for questions and answers. If you have a question, you can put it on the floor for all of us. Questions? Okay, that's great. Everything perfectly understood.
Yes, please.
Yeah, so go and work over it. Don't sleep on it. Pull a
Okay, sir.
computer. Yeah, someone has a question. Please go ahead.
Yes, sir. The insert into members. Why didn't
Yes.
you input all this thing like the
So that's an
gender?
assignment for you. I don't think you should ask this question. When you go home, do it for all. It's the same. When you're doing for two and do it for all, it's the same principle. We don't have the time to do the same thing with, for example, if I do one, and the principle with which I do the one is the same for if I'm doing 1 billion, we use the one to explain. When you go home, do it for all. You can just add and do it and see. Next time, add all of them. That provides a means for you to experiment. And experimentation is what makes you actually learn. It's not really by reading. When you read, experiment what you read. Okay? So go and do it. Any other question? Sonia, your microphone is on. Does it mean you have a question you want to ask?
No, please.
Okay. Thank you everyone for your attention. We'll meet maybe this week, otherwise next week.
Okay. Good. Well, I can't say I think.